So, take a look at the physical world around you right now. I mean, look at the device you're watching this on, the table sitting in front of you, or even just your own hands. They feel completely solid, right? They feel undeniably 100% real. But what if they aren't? What if the very fabric of everything we interact with isn't actually solid at all? What if, at its deepest, most foundational level, reality is literally just a projection? Well, welcome to this explainer where we're going to completely dismantle your understanding of the physical universe.
Today, we're looking at the overarching architecture of reality itself. We are shifting our entire paradigm from a universe made of clunky, physical matter to one built on fundamental information, code, and maybe, just maybe, consciousness itself.
Okay, let's dive into this with Section 1, The Quest for Unity. We really need to start with the most famous historical problem in modern physics. You know, legendary physicists like Albert Einstein and Stephen Hawking basically spent their entire lives searching for what's often called the God equation. They wanted this one elegant mathematical framework to unify the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces. It sounds simple enough on paper, right? But there is a massive, absolutely gigantic roadblock.
To really wrap your head around that roadblock, imagine you're sitting down for a one-on-one interview with the universe itself. If the universe started talking to you about the macro world, galaxies, gravity, planets, it would speak this incredibly smooth, intuitive, predictable language of general relativity. But if you then asked it about the microscopic world, its personality entirely flips. Suddenly it's speaking quantum mechanics, it's erratic, it breaks the rules, things are existing in multiple states at once. It's almost like the universe has a split personality. And trying to merge these two rulebooks, that has been theoretical physics' greatest nightmare.
Which brings us to Section 2, the cosmic symphony. So how exactly do we bridge that gap? Theoretical physicist Dr. Michio Kaku uses this absolutely beautiful metaphor that I just love. In string theory, if you took a powerful enough microscope and zoomed all the way in on an electron or a quark, you wouldn't just see a tiny, solid, dead little ball. You'd see a minuscule vibrating loop of energy, a string. What we perceive as all these different subatomic particles are really just different notes being played on microscopic vibrating strings, all resonating across an 11-dimensional hyperspace. So the universe isn't just a random collection of objects, it's quite literally a cosmic symphony. And as we dig deeper into these ultimate equations, it forces us to ask some pretty wild questions. Like, what if the universe isn't just dead matter? There is this growing subset of theoretical physics exploring panpsychism, or the conscious universe theory. The idea here is that if reality is fundamentally built on information and these cosmic vibrations, well, consciousness itself might be a foundational property of the cosmos. It could be woven right into the fabric of space and time. It's kind of like we are all just individual neurons inside a giant cosmic brain, constantly having this ongoing conversation with the universe itself.
Moving right along to Section 3, the quantum computing revolution. We're shifting from theory to actually harnessing these crazy laws. Let's look at how this actually works. Classical computers, like the phone or the laptop you're using right now, they run on bits, which are rigid. They have to be exactly a 0 or a 1, and they process logic in a straight, linear line. But quantum computers, they run on qubits. Imagine flipping a coin. While it's spinning in the air, it's not really heads or tails yet, right? It's just this blur of both. That is superposition. Much like Schrödinger's famous cat being both alive and dead until you observe it, a qubit can be both a 0 and a 1 simultaneously. This means a quantum computer doesn't just try one path to solve a problem, it explores every single possible outcome at the exact same time. It's completely mind-blowing.
Now, what's really interesting about this slide is the sheer terrifying scale of this power. Look at Google's new quantum chip, Willow. In late 2024, it performed a calculation in under 5 minutes that would take today's absolute fastest classical supercomputers 10 septillion years to solve. 10 septillion. That is 10 to the power of 25 years. To put that into perspective for you, that is vastly, vastly older than the entire lifespan of the universe itself. Processing power that vast is almost incomprehensible to the human brain, and it leads some thinkers to a wild, almost sci-fi realization. If quantum computers can process information at a scale older than the universe, is the universe itself just a massive, conscious quantum computer? Now sure, some physicists definitely prefer standard explanations, like the Copenhagen interpretation, to explain this without needing to get too weird. But others, they're starting to seriously wonder if this immense computational power implies an underlying cosmic consciousness. We are literally watching science blur the line between rigid physics and an alive, thinking cosmos.
Which naturally brings us to Section 4, the holographic universe. What if this whole 3D world is just a projection?
Okay, so let's talk about the holographic principle. Stemming directly from the crazy math inside black holes, physicists proved something absolutely astonishing. They found that a three-dimensional reality containing gravity can be perfectly, mathematically encoded as two-dimensional data without gravity. In this view, the 3D universe that you and I walk around in every day is basically a hologram. It's a projected image of reality rendered from data coded on some distant 2D surface.
So, the crucial point is summarized brilliantly by the legendary physicist John Archibald Wheeler with his famous concept, it from bit. Wheeler proposed a radical shift in how we do science. He said, actually, scratch that. Matter is not fundamental. Information is. Every single it in the universe, every star, every apple, you, me, derives its entire existence from binary choices, from bits of information. We are totally shifting from viewing reality as a collection of physical stuff to viewing it as a manifestation of underlying data.
And that plunges us right into Section 5, Are We a Simulation? The ultimate cosmological mystery.
Look, when physicists closely examine our universe, they keep finding things that suspiciously resemble the constraints of a computer program. Think about the speed of light for a second. It acts exactly like an absolute hardware processing limit. Or take the Planck length, a scale so unimaginably small that space-time itself seems to literally break down into discrete chunks. It's almost like the pixelation on a low-resolution TV screen. And the quantum observer effect, where particles only take a definite state when you actively look at them, that operates exactly like lazy rendering in a video game engine, which only draws the environment the player is actively looking at just to save processing power. And quantum entanglement? That's identical to two variables sharing the exact same memory pointer in a piece of code. It is wild. And then you add in the fine-tuning and coincidence problem famously articulated by Robert Dicke. The fundamental constants of physics, like the exact weight of an electron or the precise strength of gravity, are calibrated so perfectly that if you changed them by even a tiny fraction of a percent, stars simply wouldn't ignite and life would be completely impossible. Now, to some, this looks like a miracle. But to simulation theorists, this is exactly what you'd expect to see if an engineer, or perhaps that conscious universe we talked about earlier, specifically and carefully calibrated the parameters to allow complex life to form. We've traveled from the mathematical harmony of string theory to the mind-bending reality of quantum computers to the very real possibility that everything around us is simply information rendering in real time. The science is increasingly showing us that reality is far stranger, far less solid, and way more connected than our everyday senses tell us. So I'm going to leave you with this provocative thought. If the universe really is fundamentally built out of information and code, what exactly is the physical screen you are looking at right now? Think about it. Thanks for joining me on this explainer, and definitely keep questioning reality.